The Australian Government School for Teachers of Mathematics was conducted at the University of New England in January 2008. This school brought together 200 teachers from around Australia who heard high-profile presenters delivering on topics related to contemporary mathematics teaching. Dr. Beth Fulton, who's with the CSIRO Division of Marine and Atmospheric Research, delivered a presentation entitled Maths in Modelling of Marine Ecosystems. Beth, I was just wondering if you can tell us what the main focus was of your presentation.
Just to try and show them the kind of maths that's used inside those kind of models, to demystify them a bit so they don't think it's either simple accounting or mind-blowing kind of stuff. It's actually fairly simple maths. It's just a number of bits you've got to stick together. That's the complicated bit.
Right. So what would be the relevance of that presentation to contemporary mathematics teaching?
It's just to show them so they can give context to students, because there's such a dearth of people with the skills, and a lot of that's to do with enthusiasm of people progressing from high school into university and leaving maths behind them is something that they desert. When if they've got an enthusiastic teacher who shows them the context of work and leave, they can keep going with it.
Right. So in terms of messages or issues that you wanted the teachers to go away from the school with, can you outline what some of the key things might have been, more specific issues?
So some of the specific issues were that in the changing climate that we live in, that it's becoming more and more imperative that we do this kind of modelling, that it doesn't take Einsteinian levels of mathematical understanding, that high school mathematics does actually capture a lot of the skills. Right. It's more the enthusiasm to link together biology, which is classically seen as non-mathematical. Yeah. Lots of biologists do to get away from maths. Linking that up with maths so that we can better capture what's going on, because maths is a great language for describing how the world works. It's much more effective than, say, something like English or any other spoken language.
Right, so there's a common understanding of some of that the symbolism that goes in maths, I guess. Right, so in terms of the teachers' capacity when they return to their schools to take something back that they've learned, are there particular ideas or practices that they would have dealt with here that they could apply in their schools?
So a few of them have commented that they're actually, some of the examples that I gave, for instance Leslie matrices, are now explicitly a part of the curriculum. Right. And I'll be able to point to that as a direct context when someone says, what's that used for?
Yes.
We also presented them with some Excel spreadsheets to take back so that kids can just play and see how it evolves. We also tried to bring in the links to things that the kids are often very much more involved with. So computer games, for instance, use a lot of the same mathematics and ideas that are used in marine ecosystem modelling. Right. It's just it's done in a media context instead of in a science context. So pointing out to the kids where they can get the commonalities too. Yeah,
that sounds great. I'm just wondering, because we'll have on our summer school website resources that were used in the school, are there any other resources that the teachers might be able to go to help them in dealing with this particular area of their teaching?
There's a lot of Java applets up on the web, where people have taken the time to code in simple models for people to play with. So if that Excel wasn't enough, they can go to more complicated ones on the web, just Googling names like Leslie Matrix and Lotka Volterra and Game of Life and Silly Automata and all those kind of Azure-based things. We'll bring up plenty of those kind of things. But you don't actually need... One of the beauties of ecosystem modelling is that some models don't even need new actual numbers, so to speak. They use zeros and ones, and so you can do it with coloured bits of paper as well. So if you have red and green paper and the Game of Life idea where, have I got a live neighbour, then maybe I should turn over and be the live colour. Yeah. Or have I got too many neighbours so I get overcrowded and die? And those very simple rules to show that complex patterns can form from very simple rules with very basic materials. You can get that kind of message across.
Oh, that sounds great. I think there's sort of simple, basic exercises that can be done even without a computer are sometimes very useful. And I'm sure the whole area of sort of the ecosystem and people's interest in global warming and that will make it a very relevant area for teachers to actually present in their teaching. Thanks very much, Beth, for your information today.
No worries, thank you.